Welcome. Welcome to another Stat 420 video. In this video, we're going to be looking at linear modeling in R. So we're going to do some plotting. We're going to look at how to create a linear model as well as extracting values from a linear model and making predictions from that model. So I'm going to start by downloading some data from a website here. So I have some data here that's going to be stored in my global environment from this website. And this is what the data looks like. So it's birth data. So one variable that we have here is birth weight, which I believe it's in ounces. I'm not entirely sure at the moment, but I think it's in ounces. And then this other variable, gestation, is referring to how many days the mother was pregnant with the baby before birth. A lot of these are going to be somewhere around kind of 8 or 9 months. And then there's some other variables as well that we won't necessarily look at in this video, but these are primarily the two that we'll focus on here. So the first thing that I want to do is just create a scatter plot with this data. So I'm going to do a scatter plot where I'm trying to predict birth weight from gestation. So I want to know what relationship there is between number of days of gestation and the birth weight for that baby. So I'm going to do birth weight, gestation, and then identify the data set I'm working with. And so that should give me a basic plot here. And then I can add some options here as well. So for example, I could change the axes in a title, but I won't do that for now. So I'm going to do a couple things here. So I'll change the point style because I don't really like the open circle plots. I'll change the color as well. And so this should be relatively familiar features that we've seen before, but there's a couple features that I'm going to add here. One of them is I'm going to add a grid, and I can just do that by doing grid open close. I believe there's some options on here as well if you want to make like a dotted grid or something like that. Honestly, I don't really use the standard plot features in R very often. I usually use a package called ggplot2 when I'm making nice graphs with R. But if you're sticking with kind of these basic plots, which is what we have in the book, this is how you can add kind of a basic grid in the background. But as a side note, I will mention that if you plan to do a lot more data visualization in the future, I would definitely look into using a package like ggplot2. I actually have some resources for learning ggplot2 if you're interested. I might post them kind of towards the end of the semester. It's kind of a further learning thing for anybody who's interested, but just kind of a side note there. So adding a grid, you can do that by just adding kind of another line and putting it on top of the plot. One more thing that I can do is add a line of best fit, or really just any line at all, with something called AB line. And there's a couple ways that you could do this. You could either directly plug in the intercept and slope. So like, let's say I have the intercept be 0 and the slope be 0.5. I would just do that. And there is a line that has appeared with an intercept of 0 and a slope of 0.5. You can also change the line width with LWD. So I think the default there is 1. So if I do 2, it should get a little bit thicker there. And you can also change the color as well. So I think we can do color equals, and we'll just say blue, because if I do too bright, it won't really show up very well. Okay. There is also an option, once I create a model, like a linear model, I can actually plug the model name into this AB line. So I'll come back to that once we have a model here. But let's go ahead and create a linear model. I'm going to call it mod gestation, or mod gest. It's going to be a linear model with, again, birth weight for gestation as the predictor. The data is going to be births. And then I can create that here. And so that does exist. It is something that exists in my environment now. So I can extract things. I could also just run it as it is, and I'll get the slope and intercept here. So this is not a whole lot of information, which is why normally, if I want like the full kind of regression output with more information, I might do summary of this name. So summary of mod gest would give me a lot more information here. Let's see, did I click that? There we go. So we can already see a lot more information kind of popping in there. including coefficients, as well as kind of the t-test for whether the intercept is significantly different from 0, whether the slope is significantly different from 0, things that we'll talk about more in the next chapter. We also have r squared is probably the most important thing that would come out of the summary model as well. But before we get into that, I'll just kind of make a note here that we can still extract a lot of things that we can't see from the model itself. So if I just do names of mod jest, these are all the different things that are saved in this list right here, this list of 12. So these are the 12 different things that I could extract. So for example, if I do mod jest and then $, residuals or fitted values or something like that, I will get a vector of all of the residuals, though it will max out at 1,000 if there's more than 1,000 data points. So I can extract really anything that I want here. In fact, I can even make arguments of this if I want to. So if I want mod residuals, but then I want the model residuals to be greater than 10, we'll say like an absolute value of greater than 10. So I'll put absolute signs around this. So if the absolute value sign is greater than 10, I want to extract that, and then I can run that, and I'll get a list of all the residuals with an absolute value greater than 10. I can also save this, by the way. So if I wanted to save this under, something, I can. So just assign it to a variable. That would be fine. I can do the same thing with the summary model as well, right? Because there's going to be a lot of information that comes for this. Some of this is going to be the same. Some of this is going to be a little bit different. But one thing in particular I will point out is just the r squared values is what you would get from the summary that you don't get from just the model without the summary. So if I want to do summary of mod jest r dot squared, I can do that like that and extract that value. One other thing I'll mention is coefficients. So this would be important. So let me go back. This is something you can get from just the model without the summary. Is I can do model coefficients like this and get just the coefficients. And I can also extract either the intercept with the first term, or I can extract the slope with the second term there. And that will, if I do a single bracket, it gives me the label along with it. If I do a double bracket, it will produce just the value by itself. So just kind of a note there that if you're using this value in something else, you might use the double bracket in that case. Okay. We can also make predictions from our model with the predict function. Let's say that I have a particular x value and I want to know what does the model predict y to be given this particular x value. So I can do that with predict, and then I'm going to type in the name of the model here. So predict, and I'm going to have mod jest. And now this is the part that's not super intuitive. Not that it's like super unintuitive either, but you actually have to name a data frame. So I'm going to do data.frame, and then in parentheses, the predictor name, which is gestation, equals some value. So in other words, if I'm looking for the predicted birth weight of a baby that had a gestation of 280 days, then I would plug in 280 here. And if I run this, I will get that result. So this is the predicted birth weight, would be about 119 ounces, given that the baby is had a gestation of 280 days. So I can change this number to anything. I can also do multiple values here as well. So if I wanted to simultaneously predict a list of values, then I would need to use C for concatenate and then list those values inside the parentheses. So make sure you put an in parenthesis as well, because that's easy to miss there. So if I want to do 280, maybe 250, 266, doesn't really matter what order here or how many I have, but if I wanted to do all of those simultaneously, I could get the predictions there like that. So I think that's about it, except I do want to go back to the plot here and show you that once I have a model defined, if I want to, instead of plugging in these values directly, I could just type the name of the model, and that would also give me a best fit line that corresponds with the model that I created. So this first one, by the way, if I want to get rid of the first one, I should replot the whole thing again. So this essentially clears the plot. And then this line right here is going to be the line of best fit according to my summary output, according to the slope and intercept that came out of the model. Now again, my model using this data is just producing coefficient estimates, right? They're kind of my beta hat naught and my beta hat 1. There does exist a true beta naught and a beta 1 in this population. I don't know what it is. But based on this data, these are my least squares estimate for that best fit line using the particular coefficients that correspond with that according to my